welcome to this second lecture. In the first lecture we have explained various aspects of differential equations, including the importance of studying ODE as a topic of analysis. That is what we concentrated in the last lecture, and that is what we are going to do it throughout the lecture. What we have especially emphasized is that the methods available to study ordinary differential equations is very limited, and there are very handful of examples where you can actually develop methods. In fact, most of the physical problems and the corresponding differential equations cannot be solved in the sense that of implicit explicit. That means your solution y as a function of x and an implicit relation between y and t, which is in general not possible in most of the interesting differential equations. It is in this respect only we explain the concept, enlarge the concept of solutions to differential equations. The solution does not it no longer means that when there is a solution, the solution can be explained or given in an implicit or explicit form. There are also other concept of solutions which we may not come into that, but it is always important, especially when you study control theory and other physical problems. We will not come to that one, but for us when there is a solution exists, and that is this is the scenario where you need to understand, study the solutions, and the qualitative study begins there, especially the qualitative existence, uniqueness, and then of course more qualitative analysis about differential equations. In the next 2 to 3 lectures, including this lecture, we are going to present few real life examples. These examples are not new, but it is a important examples, it is available in the literature, and we will give some details about some of the examples in these first 2 to 3 lectures, and other details of some other examples you will see when we proceed the course. In other lectures we will explain to it. So, you will see also through these examples just producing even solutions explicitly or implicitly is not enough, because the solutions may not reveal its features. So, the idea, if you want to understand, you have to, even after getting the solution, you will see that you have to study the solutions in the sense of analysis. But before coming to the example, I would like to explain 1 or 2 issues which I learned from experience by going and teaching students of BSc students especially. There are certain issues which are not clear, not only to the students, and is also not explained to the students by the teachers properly, and we want to spend some time, maybe 10 minutes on that. And if those who are already thinking that that is trivial, they can just get out, bypass this part of the thing, and they can get into the examples directly. So, let me start with an example. What do you want to do it? This is an example from integration. So, I am going to from the integration theory, as you know that the ODE started from the integration theory. So, I want to start with a very simple example which you do it in your +2 time, and that is where our all trouble quite often starts. Certain steps are not clear to it. Look at the integral, you want to do it y cube dy, you want to integrate it. There are 2 ways of doing it. You immediately know that what this integral is, so you immediately write y power 4 by 4. That is fine, there is no problem, that is good. But you do not know this thing. The another way is, which is important, here you are able to do it because you know the antiderivative, you can do that one, but then when you do not know antiderivative, the integration is done via substitution. So, what do you do it? You will substitution, you will do substitution what you do is that suppose I put y square equal to t, one substitution need not be unique, or equivalently y equal to root t. The immediate step you write is you will immediately say the next step, you will never think of that, you will immediately write 1 by 2 root t dt, and the next step in the solution you write is therefore. This is what the steps you are writing in your 12th standard, exactly I am going to write, and I want to know that y cube dy is equal to y square is your t and your y dy, y square is t. So, dy is equal to otherwise we will write here 2y dy is equal to dt. So, let me use that one. So, one of these both ways you can write it. So, 2y dy is equal to dt, and you immediately say that. So, y dy, y square is substitute as t, y dy is half dt, you write half dt and you write t square by 4. This is the procedure you follow, which is nothing but y by 4 by 4 answer. So, what is not clear, which I never got an answer from the BSc or other students when you ask what do you mean by this. This is where the first difficulty in understanding coming to you. What do you mean by, what is the meaning of dy dt? If you do not know the meaning of, so that is the first step, and we never, most of the time we never get a satisfactory answer to that. In fact, we do not understand this, we do not know it, we do not know at this level. That is important, why I say that at this level, when you study advanced differential, advanced topics in mathematics like differential geometry etc., then you do interpret this in a different way, but that is not the thing we have to understand at this stage. So, when you do not know dy and dt, how do you so the question is that what is this, what is 2y dy is equal to dt. So, I want to spend a bit of time here, 2 minutes here. So, here is the what is your trouble you are to, what you know really is, so you have to understand that when you treat y as a function of yt, that is what we are doing it, we know what is dy by dt together. This you are as a function of t, you know what is this. You do not know what is dy probably, you do not know what is dt. This is a symbolic representation, this is a notation to understand the meaning of this limit, limit delta t tends to 0, y of t plus delta t minus y of t by delta t. So, you have the meaning for as a whole of these things, but you do not have the individual meaning to it. So, that is what you have to. Okay. So, that is what we are. Similarly, I will come to that example together. So, similarly, let me start with one more example where a similar lack of understanding. This I want to do it because differential equation, similar thing, how you proceed here. You have dy by dt equal to a of y. In the similar way, what you write is that the next step you write is that all of you will write dy by dt. So, dy by y is equal to a dt. This you do it immediately, and then say that on integration you immediately write integral of dy by dy is equal to integral of a dt plus some constant, integrate, you get your log y. These are the steps written quite often, a t plus c naught, and finally with one more step you write y t is equal to c e power a t. Good, the answer is fine. See, the whole thing is that in the previous example the answer is right, even the answer is correct here. So, again the issue is that what do you mean by dy by y is equal to y. and this is what verse is an arbitrary constant here. So, what is the meaning again? What is dy is equal to a dt, dy by y is equal to a dt. To do that, because to explain this one, if you want to understand this one, if you want to understand this, you have to understand dy. And here is a important result we quite often bypass, but that is one of the important aspect when you want to study the not only the integration theory, many other things. Whenever you develop an integration theory, you have to understand one of the important result what is called the change of variable formula. So, we will introduce in our preliminaries change of variable is what is the underlying principle behind all these things to explain to use that. So, what I am trying to say is that all these are all. So, when you recall the first example, when you have when you call when you writing this one, this is only a symbolic representation of this fact, that is what I am saying that. So, as such this has no meaning. So, you have an expression here say 1, you have an expression here 2, you have an expression here 3. What I am saying that 1 and 3 have meanings, 2 is only a representation of the fact 3. What you really need to prove, derive 3 from 1, and this is the part here, the part dy by di equal to y, you have to view it as a step to represent 3, and this is where is given from the what is called from the change of variable formula. How does a change of variable formula looks like, which is what we are going to explain, but you will see it in the preliminaries. Suppose you want to integrate integral of suppose you want to integrate f of y dy, and you are making a change of variable. That means when you are change of variable, here y you view it as the variable, here view the view y is the independent variable as far as this is concerned. Okay. And then you are making a y going to equal to as a making a change of variable as a function of g t. You have t, you see you are making. So, you are having the independent variable y, you are making to a new variable t via this relation. So, in that case f of y will be f of g of t, you see, and thus this can be viewed as a function of t, you see you have a function of t, and hence we can integrate h, with respect to t. So, the question is that what is the relation? What is the relation? This is given by the change of variable formula. This is what is given by change of variable formula, which thing that mean you if you integrate this one f of y dy is equal to nothing but integral f of g of t g prime of t dt. This is non trivial. So, it is not immediate, need a proof, of course need a proof, and this is what you will be seeing in the need a proof, it is not trivial. Okay. This is what I want to say that. So, whenever you making an integration is introduced, you have to always prove certain types of change of variable formula. Unless we do that one, we will not be able to proceed further, we will not be able to integrate quite often many interesting functions. So, the change of variable formula is very very important when you study any integration. Whenever you, that is you might have studied on just not just one integration, many other types of integration you will come across with that. Each time you have to do a change of variable formula. This is also important when you have a multi-valued function. Suppose if it is a function of different variable y1 etc. yn, how do you change it? Then the change of variable formula is much more complicated. You will have in terms of here certain Jacobians etc. there. Okay. And whenever you make a substitution y equal to g of t, the normal procedure you immediately write dy is equal to g prime of t dt. What I am trying to convey to you is that this is only a symbolic representation of this fact. So, whenever I am telling that you can integrate into whenever you have function f and whatever, if f equal to 1, you will have integral of d of y is equal to integral of g of t. This is the fact used here. So, as such this has no meaning. If at all you are going to give meaning, is that you have to give this meaning to this fact, this one. With this change of variable, you will they may in the preliminaries we may say few more words about it. There will be, of course, if it is a function of y, you will get a function of t, but you have to resubstitute t in terms of y. All that facts are there, essentially that one. So, or you will have the limits for this integration, then there is no problem. If it is not limits, you have to resubstitute back, that is what it is. Now, let us recall the facts. Now, recall our example, recall example 1, and I do not want to use it because I do not have anything meaning to that. I want to prove everything just using my integration. Recall example 1, 2 examples we are doing, an integration theory example. What is the first example? You will have f of y is equal to y cube, and then you have substitute y square is equal to t or y is equal to root t. And then I want to understand the integration now with this relation to that one. So, I am not going to write dy equal to something, because that is a simple I am not going to use dy equal to d whatever 1 by root 2 d dt at all, because that has no meaning. So, I want to understand the integral of that one. So, what is your y cube dy here is equal to change of variable. Here is a change of variable, this is the change of variable. What do you want to string? Instead of the change of variable, I want to substitute y square equal to t. So, f of that, when I put y is equal to root t, I will get root t power cube. And then what is my g of t here? This is my g of t, you see. So, I want g prime of t. So, I want root t prime dt. So, when I write this one, so I have not used anything, I have used the change of variable formula. If I substitute that one, I will get it t power 3 by 2 1 by 2 root t dt is nothing but, so I have arrived that half of t half cos t t dt. So, you see, so you arrived that formula integral of y cube. I proved this third equation without bypassing that thing, you apply just that and then you proceed it. So, this is your first example which is. So, whenever you do it, we will also write this thing now onwards. So, whenever we write something like this, dy equal to something like g prime of v, keep it in your mind all the time that there is something relation to this one, some sort of, that is the meaning of it. So, you need to prove it, you need to require a change of variable formula at all point of time to conclude that one, you see. Now, we will come to the other example as also, differential, the example 2 which we have done, example What is example 2? You have your dy by dt is equal to a of y. You see, I do not want to write dy equal to dy by y equal to a dt. Eventually we will do it as that, but we have it in mind. So, I want to write this is dy by dt is meaningful, I told you, because it is a function of t. So, there is no problem. So, I can write y is meaningful. So, I will write 1 over y dy by dt is equal to this all function of t. So, y is a function of t, dy by dt is a function of t, you will have a is a constant which is a function of t. So, I can integrate when I integrate with respect to t, what do I get it? I get 1 over y of t dy by dt which is a function of t dt is equal to integral of a of t a of dt a of dt plus some constant of integration. Do it. Now, change of variable. What is the change of variable here? Again change of variable here t to y. You can make change of variable anywhere you like it. I want here the change not actually earlier it was y of t. So, I want a t going to y. I want to view instead of t as my independent variable, I want to see y as my independent variable, and I want to see, as you know very well, 1 over y is the function coming into picture. So, I want to integrate 1 over y. Now, I am viewing y as independent variable and I am differentiating. So, my f of y is 1 over y here. Here f of y is 1 over y and my g of t is equal to that. So, here f of y is equal to 1 over y and my g t is nothing but y of t. This is what you are doing it. So, if I do that one by change of variable again, change of variable formula again, here I have my thing, I need view this as a function of t and I want to differentiate this. Why? Differentiating is that is nothing but my dy by dt, that is it, y prime of t I want it, and I can integrate dt. Okay. I have t into dt, you see, and this is nothing but this left hand side of this one. So, hence that implies if I substitute this for this term, I will write integral over 1 over y dy is equal to integral of a dt plus c naught, you see. So, you arrived at this formula with a change of variable, and this again symbolically represented by dy by y is equal to a dt. You see, I want to say that this is it, this cannot be derived from here, this formula cannot be derived from here, it is not directly derived, it is the fact of integration parts. So, this is the one important thing I would like explain. And one more fact which may be looks simple, but I have seen lot of students making mistakes. Another issue probably trivial to many of you, but I feel that I want to clarify this one because we are going to do this again and again. The other issue which you are again with these examples, let me explain to you. This is equal to ay. So, now symbolically let me write it because the meaning of this is understood. Now, I can write this with when I write this one I have something else in my mind, right. The thing is that there is an integration for a change of variable formula. So, symbolically we are going to do this again and again, but and then the next step most of the time we write log y or log natural, you can use it. Log y is equal to at plus C naught, and then that you will write eventually y of t is equal to some arbitrary constant into e power a t. Fortunately, you get the correct solution, no problem, correct solution. But this is not entirely correct while you are writing it, though you have a solution here. When you integrate here, when you integrate this one, what you get is really log mod y is equal to a t plus C naught. This is what you will get it, and then from there you will get modulus of y t is equal to C e power a t naught, that is what you will get it. So, how do I arrive? Mod y is, you may not be able to differentiate. So, how do you get, how do I get my correct solution from here? So, that is a best, how do I get my correct solution? So, here is something which I want to tell you, you may be able to follow that. Write this, maybe I use a different color, write this as modulus of y t into e power minus a t. These are simple things, but the moment you understand the simple things and the difficult things are the combination of simple and easy things. There is nothing like difficulty per se. All your simple and easy things, if you put it together, things looks very difficult and you want to change it. So, it is your job, any student's job or any teacher's job is to understand things the easiest way possible. So, here you have a constant. Here is again one need to use one of the important thing what are called the continuity of the function. Okay. So, this function being differentiable is a continuous function, okay, continuous function. And another thing, since this is a modulus, this formula is valid, C is greater than or equal to 0. So, here itself this is a positive quantity, this is a positive quantity, hence this is valid. Of course, this is coming something like e power C naught. So, it is greater than or equal to 0. So, you will immediately see that this is not for any constant for negative thing, but this is a continuous function. Here is a first small exercise for you, which you should do it. So, whenever we are giving this course, we will be leaving lot of gaps in the proofs, we will be leaving small exercises for you, and that you have to work out before going for the next lecture. So, study the entire course by lecture, solve the problems, solve more problems, get into the books, try to understand more examples. We may present only 1 or 2 examples, but you try to get more and more examples and then you present it. The example, let f from R to R continuous and modulus of f is a constant, This is a very simple example. The moment you learn continuity, you will be learning, but if you know it, you follow that. F is a constant, then f itself is a constant. Okay, that is the thing. If you have a continuous function whose modulus is constant, then the function is. This is not true if f is not continuous. This is not true if f is not continuous. Find the example, not continuous. Find examples. Trivial examples are available, but you can find that one. Okay. With this observation, this is a this is a continuous function, this is a continuous function, you see, and whose modulus is constant, hence this continuous function y t into e power minus a t itself is a constant. Okay. So, you will have, so that implies the example the exercise implies y t e power minus a t equal to c is a constant. What is the difference from earlier? This constant can be negative, where c can be negative as well, can be negative as well. So, that is why I call it very arbitrary. So, these two important small observations which you have to, one has to be very clear, and you have the correct solution which you, we see this kind of small facts in your study, not only in ordinary differential equation, with other equations as well. And for now we are going to give few examples in the, as I said, in the next few lectures, 2 to 3 lectures, and we will start with some physical models. So, we are starting with physical models. So, today now to complete this, I may just do one example, example 1. You have the population model, this is what we are going to do it, and our, it is easy for you to solve. Those who have studied any differential equation, they will be able to solve it immediately, but the purpose is not that. We want to see how we use the analysis to derive more about the knowledge of the trajectory population model. So, there are two things, one is the linear model. So, we will start with the linear model, and then we will see that linear model is not always correct, not always be the good model. Then we will go to the one of the famous non-linear model given one by the biologist, we will come to that. So, we will go to that one. So, we will have the linear model. So, suppose my y t represents the population, at time t. So, let me population at time t. I want to do that one. So, how do you suppose is a population is growing just based on the population, no influence from anywhere else, you have enough space, no competition, no natural disasters, nothing. It depends only on the population of the number of people available. So, it is a natural way to think that suppose you have 2 cities or 2 systems, in which one system you have n number of population, n is the population, other one is the 2n is the population. Then after an year, if there is a growth, if it is a normal procedure, the extra population in the first system, and if you compare the extra population in the second system will have the double the extra population than the first population, you see. So, the simplest and easiest model is that your rate of change will depending on the population. How much it will grow is what is called the population rate. So, there will be the rate, then a simpler model will be dy by dt, the rate of change of population with this phenomena, with there is no other things, will be proportional to y itself. That is the easiest model, and that gives you your linear model dy by dt is equal to some r into y. And you have seen, you already solved instead of r with a, you already solved this equation. So, suppose, so you will get the solution, you see, solution y t is equal to some constant into e power r t. You see, you have e power r t. So, if at t naught your initial time, wherever you can put your initial time, you know the population, say suppose the population y t naught is equal to y naught, then that will imply if you substitute at t naught you will get y naught. So, your population will be y at t will be y naught e power r into t minus t naught. You can evaluate and do that. These are the small steps, but I always suggest to the students that you better work out. It may look trivial, but just substitute t naught and do that. That is the way you have to learn the mathematics. Okay. So, you have your solution, easy way you have the solution completely. Now, you can immediately see observation, that is what I said. You got the solution, do not stop there, you have to always analyze the solution what happens, and especially when you create a model of a physical phenomena based on observations, data and all kinds of things, you have to see that your model is actually true, whether you are actually you are able to predict your thing, whether your model goes wrong at some point of time and it does not really give you the represent your physical phenomena. You have to, that is what is after the analysis which I represented the schematic diagram last week. You have to, after doing the analysis, you have to go back to the modeling once more, and you may have to, you may need more data. That is what I explained, you know. So, you see that an immediate observation here, this you can prove mathematically, of course is easy. As t tends to infinity, your population y t increases to infinity, but this is not a desired state of affairs. Nowhere in the universe you can have a population as time goes, the population will goes to infinity. What will happen is that when the population increases to infinity, when the population becomes bigger and bigger, there will be much more competition between the species. We are analyzing here only about one species. There will be there are systems which we may explain at least one example later, more than one species, where even with just one species we are analyzing this problem. So, within the system, the two species, two persons or two bacteria, it can be a bacteria whatever it is, there will be competition between for food, space, everything, all kinds of competitions. So, we are looking into a model where there is only a competition between them. Still we are not taking into account other aspects like natural disasters and things like that, and that can also, and also the population can come from other places to this one, all kinds of things can happen. We do not take. So, we are going to give you a nonlinear model now, as this model is not suitable when this model is not suitable when the population is not. This model is reasonably okay when your population is not too big and it is a known fact, but so we are going to give a nonlinear model. So, going to introduce a nonlinear model with just one fact, that you are taking into account the competition between the species within them, not the competition with the species with another species. So, the competition, and this is given by one of the famous Dutch mathematical biologist, Dutch mathematical biologist. It is a Verlust is called what is the spelling, I think just this is given probably in 18 something like 30s or something approximately. So, how do you take into account? So, let us anything to understand, anything to model, you have to have an intuitive feeling about that. Suppose you have a population with n people, what are the possible number of competitions a person can meet all other people. So, a person can meet that number of encounters, this is called, basically I am trying to give a statistical average. What are the number of encounters? A simple thing we will get it. Can the number of encounters is that the first person can meet n minus 1 person, maybe the next person can meet n minus 2, like that. So, the number of encounters will be thing, if everyone meets everybody, that will not win. That is where you have to understand the population and then you have to put a factor. This is something like equal to n minus 1 into n by 2, that is in the order of n square. So, the this is approximate. So, if n is the number of people in a population, the number of all encounters between each person meets one is order of n square. So, it is the message is that it is of order square, but not that everybody will meet. So, you have to understand when you are modeling it, you have to understand on what fraction, and this you have to understand from a particular thing. And what was given is a model, then dy by dt, you have already you have the factor r, let me use it a now, that r is the same as a here ay, but then due to this encounter you are saying that two persons meets, encounter, they get killed, maybe two bacteria meet, they attack, because both of them will be trying for the same space or same food. So, they one of them they do the fighting and one of them will survive. So, it will reduce the population, it will be in the order of y square, but not that everyone will meet. So, there will be a factor. So, as I said, for a particular problem, whether it is a bacteria growth, human population growth, study how to choose A and B depends on the particular population, which we are not going to give it here. It has to do a statistical analysis, you have to collect the data, how over a long period of time, and you have to evaluate A and B for a particular population. Even for a particular population, it may work for a certain period of time. So, you have to do an update, maybe you will make a remark again later of that one. So, you have a nonlinear model, you see this is a nonlinear model given by dy by dt is equal to a of y minus b of y square. And suppose your relation at initial time y naught is equal to y naught. So, you have a very nice initial value problem, you see. So, two steps we want to do it here. So, as I said, we are not going to give you all the details about the problem. I would request the student to go through it and fill up the gaps whichever is missing there. So, first you want to solve it if possible, always that is the thing, solve it if possible, that is the first thing. Then do the interpretation, just solving is not enough. After that I want to understand, just like in the previous example which you have seen, which like previous example your population is growing. I want to understand a mathematical study of that equation after getting the solution. The solution may not reveal this one, and analyze it. Okay. And this is what we are quickly going to do, that one. So, you have the problem dy by dt, again let me write, initially we go little more slowly, y square, y at t naught is equal to y naught. This all of you know it, you can use my change of variable concept, or now you know that what does that mean, you can do the same thing, you can write down your 1 of a of y minus b of y square dy. This is formal, but I can still write formally. If you do not like now, Now after seeing that, writing this is you have to be you have to see this with pinch of salt. Whenever say that, there is an integration formula. You can divide with the dy by dt equal to 1 and do the same procedure to do that one. So you will after that you integrate and put a constant, no problem. This is fine, how to integrate is all right. Now how do you integrate this one? In the of course you would have studied how to integrate this one. This integration is done via partial fractions. You can write down, so you do go and do this, you have to do it. By square you can write it as probably you can write it as, I do not do the computation, but you should do the computation when you study this course, 1 over y b a minus b of y. Okay. Do the computation, is an exercise, whatever I am leaving are part of the exercise which you should do it. Instead of writing the exercise at the end of it, we will write the exercises here. So do the computation, okay, do that one. Once you do this one, so these are in the 1 by y 1 by a minus b5 form. Now you write it everything. Yeah. One minute Ram. It's fine. Okay. Okay, we will continue. Okay. Do the computation. So this is not minus and this is plus. Do this one. So this is in the log form, this is in the log form. Make sure that everything is writing in the modulus form. Do not make the mistakes like writing 1 by log y, 1 by log of a minus by. What you have to do is that, so that is the next exercise for you, to get it, you produce a solution and implicit form, implicit representation, you prove that representation of solution. How do you get an implicit representation of the solution? 1 over a log mod y by mod y naught. Y naught is positive because that is given to you, y naught is a positive quantity which is given to you, or can be 0 also, no problem, but here it is greater than 0, into modulus of a minus by naught by a minus by. To get that one is equal to t minus t naught. So you have a solution representation. You see, quite often you stop at this stage. I do not want you to do that. Okay, this is for t greater than t naught. This does not say anything about you do not understand how your y behaves. Though you may complete that I have a solution to your problem, I have an implicit relation connecting between y and t, but you have to do much more in this analysis, and that is what we are going to do a bit more thing. We have to see few things about it quickly. You will learn these facts later. Dy by I am telling you a few facts, but you write it properly to complete it. Dy by dt is equal to ay minus by square. Look at this expression now. When y equal to 0, RHS is equal to 0. That means these such points are called equilibrium points. and whenever you have y equal to 0 and if you have solution y at t naught starts at 0, then dy by dt will be 0 and it remains to be 0. So, you get y equal to 0 as an identical solution, it does not move. So, it is an equilibrium point. So, the solution starts at the origin at 0 at t naught. If the solution starts from 0, the solution will remain to be 0 all the time. The interesting thing is that there is another equilibrium point, there is another equilibrium points, What is that equilibrium point? This can be ay minus by square can be written as y into a minus by. So, when b equal to y equal to a by b, one more point here, normally b is very small compared to a, that is again a thing, a fact which you have to tell. Then again this is 0. So, again you have a second equilibrium point when y equal to a by b. So, if you try to draw this thing here, so if your population, so the a by b will going to play an important role here. So, if you have your population, if your population starts at t naught, this is the t naught, and if this is your y equal to 0 graph, that is nothing but y equal to 0 graph. So, if your y t naught is equal to 0, your y t will remain to be 0 all the time. The same thing when you have a curve, this is the curve y t equal to a by b, y equal to a by b curve. So, this is also an equilibrium point. So, at t naught, if your solution is there, the solution will remain to be there. And then it is an interesting fact that two trajectories, all that you will be learning here in a two trajectories, the two trajectories will not meet. So, whenever your initial population is somewhere between 0 and a by b, the entire trajectory will be somewhere here. We do not know, we are going to understand more of this graph. Similarly, if your trajectory is somewhere here, the trajectory will here. So, what it shows that, what I am trying to say, that if your trajectory y naught starting between the population 0 and a by b, 0 y naught less than a by b, the exercise is that you have to explain these things, whatever I have explained, do it and write it properly. And this trajectory, so if you have a proper thing, the trajectory will not come here, this you will be learning. You cannot cross that trajectory, because the moment you come here, it will remain there, you cannot come there, you cannot cross this trajectory. Similarly, it cannot even go here, such trajectories will not exist. If you take here, the trajectories will not cross here if you start from initial point here. So, that immediately shows, even though intuitively it is correct, so the eventually what I am trying to convey to you is that your trajectory, the solution y t will always remain to be positive between. So, you see, even though intuitively clear, yes, the population goes, but if you have a non-trivial population to start with us at y naught, if you start, your population will always be positive, okay, and that is the fact you are using it. So, so from your solution, so what I want you to prove eventually is that use these facts, whatever I have explained, use the fact explained, use these facts to show that y t you already seen, y t is always positive, one thing. The second part is more important, a minus b y naught by a minus b y is also positive. This is an important thing you want you to prove it. This is what I explained from the earlier graph. This graph, what I say that if this is one fact, there is more information, because this is y t equal to a by b is also a equilibrium point. If y naught is between a by b, y t will not only positive, y t will be remaining in a by b here. Similarly, if y t is greater than a by b, y naught is greater than a by b, y t will also remain greater than a by b. Hence, the solution which you see it, the solution here you see here, the solution which we get it, this will and this will retain the sign, and hence the whole thing will have the same positive sign. It will retain the sign because it will, and this is what you have to prove it to prove this one. So, prove this. This is an exercise for you. Once this is positive, the entire modulus can be removed from the solution. If you look at here, the entire, this is positive, the entire modulus can be removed and you can write your solution. So, that is where next exercise thing for you, the exercise. So, it is a one by one exercise. Write the solution now in explicit form. Earlier you got it in implicit form. Write the solution. Write the solution as y of t equal to a y naught by b y naught plus a minus b y naught into e power minus a into t minus t naught. Prove this. Write down this thing for t greater than t naught. You see. So, you have an explicit representation, and still this is not enough for us. We want to understand it a little more about it, and probably we will do that in the next lecture. We will little more time, another 5 minutes I will spend on this equation in the next lecture. And one thing you can immediately see is that y t, as t tends to infinity, this fact goes to 0. Once this goes to 0, y naught and y naught will get cancelled, y naught and y, this will go to 0 and y naught and y naught will cancel, and you see that limiting behavior. So, the limit goes to y t goes to a by b. You see, that is what it is. So, wherever you, even if it is a very small population, the population will go to infinity. We will see these facts in the next lecture, and we will do further examples. Thank you.